more libc and zig. So let IRC know. All right. Somebody let me know about there's a streams channel. Also didn't know. Thanks. Very cool. So we've made some good progress on libc so far. What can we do? We can build, we can link Lua, which is really cool, but we do get a crash. And I've spent a little bit of time trying to debug it. I've added like all these print statements, and for some reason there's this value that's getting pushed on the Lua stack that has the wrong type. This type 170. So I've been like getting deep into the Lua interpreter implementation to try to debug that. I still haven't figured it out. So I might come back to that maybe after I've gotten some more functionality implemented. I've also included CMPH, which is a perfect hash generator. And that's what I've been working on next. It seems like pretty simple. It doesn't use too much from libc. So I can build it, compile it, and run it. And then I get to, I'm assuming the beginning where it calls Getopt. So that's what I was going to try to do today, was to implement Getopt. So let's take a look at that. This would be in the POSIX part. I've split up libc into what's defined by the C standard and what's added by the POSIX standard. And Getopt, actually I don't think it's in the, no, it is in the POSIX standard right here. Okay. So how do we implement Getopt? Let's pull up an example here. Okay, so Getopt passes some information back through global variables. If I look at the header, it's in the UNI STD. Hey, Slim Sag. Yeah, I'm super excited to have it as well. To be able to have this all in Zig, and hopefully we'll get like stuff working on Windows. I know with your like mock engine and stuff, we could really leverage some of this, I think. So I'm really trying to like, you know, get the final solution going and get Zig to actually work really well. So, all right, let's take a look at Getopt here. Okay, so we've got this. These are the 4 globals that come in and out. Oh, Luke, hey, how's it going? Yeah, I'm super excited to have this as well, which is why I'm working on it. Okay, so optarg, opterr, opt-in, and opt-opt. These are all like the globals that let you interact with Getopt. Getopt is a weird function. Like you pass in stuff and then you get stuff. Some of the C functions are like that. It's really weird. Okay. I'm going to copy these globals here. Okay, so these are the globals we're working with. I'm going to put this in a comment in here. Return some information through these globals. Okay. And let's add a trace statement here. So trace.log getopt argc equals argv equals for now we'll just print the pointer to it. Opt string, we'll want that. Okay. So argc, argv, and trace.fmt stir of opt string. So this format stir is a custom formatter that will include things like the first 20 bytes of the string. If it's, it'll tell you if it truncates it. And it's really nice. So let's take a look at what that gives us for CMPH. Okay, so why didn't we get a trace? Oh, I need to turn on tracing. Cool, so it's calling getopt. It's passing us this getopt string. And it looks like it's truncated. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So we could increase that. I don't know, let's make it 30, maybe that's better. Yeah, so now we don't see the ... so. I'm not sure I like this syntax here. It's like you got the double quotes telling you what the string contents are, and then the ... dots after. But I don't really want to put it inside because then how do you tell if it's actually a ... versus it's a truncation? Maybe I do like a trunk. Yeah, I'm not sure what to do here. Trunk. Yeah. If anybody has any ideas, let me know. Okay, so we've got all these. So as I understand it, all your options are one letter, I think. And then a colon means that it accepts an argument. And I think that's it. If we take a look at this example here, ABC colon. And then, okay, and then it's passed in through the opt-arg global. Okay, so there's also a question mark case. If opt-opt equals C. Oh, that must mean like, so maybe question mark means that you got an argument and it's missing, and you got an option that's missing an argument maybe. Or it could mean that it's an unknown option. Okay. Oh, this example is perfect. It like handles every case. It seems like. Okay, so this seems pretty simple to implement. Let's take a stab at it. So how does getopt handle? Let's handle dashes first, and if there's not a dash, we'll just throw starting out. So if, and we can use C functions here, which I think makes sense in a lot of cases. In this case, we're just going to be checking. So we want to check if it's a dash. So let's say if, hold on. How do we know where we're at in the argv? So So maybe we should print the global information as well here. Yeah, so let's go opt-end. Maybe that's how it keeps track of its state here. Okay, so I like to put all my global state into a global struct here. So we'll say export var optarg. What is optarg? It's going to be null terminated u8. Okay, and the rest are integers. Okay. So we can just like say error equals this, end equals this, and opt equals this. Yeah, opt error. Okay. Maybe I should initialize them to 0. Yeah, I think I have to actually. At least end. So I'm guessing opt-end will be the static state that keeps track of where we are within argv. So let's try that. If opt equals argc, or we could say greater than equals, I suppose. Maybe that's better, I don't know. Then we're done, so we'll return -1, yeah. Otherwise, const arg equals argv, opt-end. And then I suppose we'll increment it here. Okay. So now we've got an argument. Now we could check whether it starts with a dash. So let's start with that. If arg0 equals dash, then we do one thing. Otherwise, I'm guessing we return a question mark if there's no dash. Maybe let's try that. Return question mark. We'll try that, see where that gets us. Expected usize found cint. Okay. Exported symbol collision. Who is... Oh, I must have put that in libc. Wait, where did I put it? Oh, I already had it somewhere. Opt-arg. I had it right here, right above it. We can put it in global, that should be fine. Okay, 36. Array access of non-array type. Oh, because it's optional. If we treat argv and we only consider the argc values, I suppose this wouldn't be an optional, so we can just change the type there. Okay. And that means it's no longer, we don't need to worry about it being sentinel terminated. its sentinel value. Okay, cool. So, well, that's interesting. It set all the values to 0 anyway, even though I said they were undefined. I'm going to leave it for now. So it called Getopt, and I'm guessing, let's do another trace here. Trace, Getopt, return, question mark. Make sure we see that. Oh, we don't see it. So how are we, oh, maybe we're returning here. Yeah, okay, so opt-in is greater than or equal to argc. Oh yeah, argc is 0. 0 argc, that's kind of weird actually. How is it getting an argc of 0? What if I like give it an argument? Hello. It's still 0. So argc is going to be, so this is called by zig. There's a zig start. Zig start? Yeah. So this is going to be the entry point for all the C programs I'm building with this. What's nice is we're using Zig's main, so it initializes Zig's runtime. So you can see here we get full stack traces in our C program. So we can see, oh yeah, here's where we are in the CMPHC program. Interesting, it's trying to print the usage. Okay. Okay, so this is going into the printf implementation that I wrote last time on stream. And, oh. We're actually crashing in the trace statement. That's interesting. Let's take a look at this real quick. Line 41. So we're trying to print the string passed to strlen, and it's a sentinel terminated pointer. So what we do is the trace will iterate through it, and then if it gets to 30 characters without finding the sentinel, it just stops and will just print out up to 30 characters. So what's the error here? Segmentation fault when we're checking slen. So it's like we've moved past the buffer and we never encountered a 0. If s equals null, oh, do you think s is null? Oh, it is that address area, you're right. Okay, so we're getting past null somewhere. And so strlen is getting null. Thank you, SlimSag. What happens when you pass null to strlen? What's it supposed to do? Null. Let's take a look at muscle. What does it do? S. Kind of looks like it's assuming it's not null. Okay, so why are we getting past null? Let me run it one more time. Okay, who's calling this? This is getting called by our vformat function. Line 39. Okay, so this is an S specifier in a format string. So this is coming off of the VALIT, the vararg stack arguments. So it's coming from this printf. Oh, you know, yeah. Okay, so remember how our argc is 0 here? It's like our argv is not getting populated. And so the first argument here, where it's trying to print PRG, it's like it's null. So then it tries to print this. Yeah, okay, so we understand what's going on now. So it looks like the problem is that we're not passing in argc and argv properly. So let's take a look at zig start again. That's because we're not populating argv. So there's the problem right there. You forget like what stuff you haven't implemented. Okay, so on Linux, let's just do this for Linux for now. So we'll say if let's do this. If built-in.os.tag equals Windows, then we'll say standard.log.warn. Getting command line args not implemented on Windows. Okay, that's probably good enough. Else args equals standard.os.environ, maybe. Actually, SlimSag, this is kind of relevant because you had that PR that was trying to make it an error to access this on Windows, I think. I think it was environ. I can't remember if it was that or if it was something else. Args. Standard.special.c already has a lot of libc. I was not aware of it. Let me take a look at that. Special standard special C. Let's take a look at that. C.zig. Yeah, get AMV, that's what it was, yeah. Okay, oh cool. We've already got string functions, that's sick. Damn, I wish I would have known about this before I implemented these. Oh, that is funny. Okay, let's take a look at, let's do a comparison here. Source libc.zig. Okay, stir copy. Let's see. Okay. So yeah, I just called the. So here's what we'll do. We'll go standard.c.special.stir copy S1, S2. Big build libc test. Oh, got that wrong. Special and then C. Oh, special might not be exposed. I think that's why it's called special. Let's see, so how am I going to get access to it? I think it's not exposed anyway. Special, yeah. I think that's why it's called special. How do I access it then? I believe it's automatically being loaded when you link libc. Okay, yeah, see, we're not linking libc, we're deliberately not linking libc so we can use our own. Okay, I might have to come back to that. We could We could also submit a PR to expose it. We'd probably want to move it out of special and put it in something else like standard dot libc or something. But I mean, the idea is to put this in the to upstream this to the compiler at some point as well. So I'll have to think about that. But now that we have that, see what I could do is I could actually make the Zig compiler a dependency of this project, and then just include that source code. So what I'll do from here on out is I won't implement any more of the libc until I see if it has an implementation in there, and then I'll do that. Yeah, I'm planning on upstreaming it to Zig. Fully. Yeah, that's the idea. This is my attempt at getting Zig further along on that path. So and there's more goals to it. We want to be able to take glibc and either auto-generate headers for any version of glibc or define a set of macros and have one set of headers and have it, sort of morph into any glibc version based on those defines. And same thing with the other big goal is Windows. So having a libc implementation for Windows, because Muscle doesn't work for Windows. So the goal of this one is to support all platforms that Zig supports, which will make the libc situation on Windows much better. Cool. So thank you very much for that pointer. I will definitely be taking advantage of that. Okay, so we're back here. It doesn't like the type, which makes sense. I think is environ. Let's look at environ. Standard environ. Okay, so it's a slice. Zero colon null. Shouldn't it be? Oh, it's an array. So sorry, it's an array. So okay, we don't actually want this to be an array anymore. Let's do this. Const args. We want this to be a pointer that's null terminated with an optional pointer that's null terminated. And then we can set it to a default, or we can just say equals undefined, or maybe we just say equals block. And then in this case, we return this. Otherwise, maybe that's what we do. And then in this case, it won't be an array anymore. Okay. Okay, so now I think it should be pointer. Okay, so, is standard OS environ, is that the actual, let's double check how that's populated, because that may not be null terminated. It may be a copy that Zig's runtime makes. Special start. No, it got moved out of special for some reason. Environ. ENVP, okay. Call main with args. Okay, so it gets it from, it gets it from the stack here, which in that is it copying it or no? Okay, it's counting it. So it's just making a slice. So it is null terminated. env can change at runtime, so I don't think a copy would be valid. Yeah, I was just wondering if it did copy it, because the one that Linux gives you is null terminated, and the one that we passed to C has to also be null terminated. So I was making sure it wasn't copying it and then making it not null terminated. So it doesn't look like it is, though, so I think we should be good. Okay, so in that case, I believe we can cast it. Oh, let me check it one more time. Yeah, we should be good to go here. Pointer cast to null. Okay, that should do it. That looks better. Okay. Or hold on, it still says argc is 0 for some reason. Oh, it's because I'm passing 0. How do we want to do this? Let's see. Var argc cint. I'm just going to write that. I'm not sure what I want to do here yet, but I'm just going to do this for now. Int cast cint. Okay. Okay. argc is 126. That's pretty big. How did that happen? argc equals wait, why is it 126? It doesn't look right. The heck? Well, let's print them out. What's what are all these 126 arguments being passed? Cannot format pointer without okay. Isn't environ the environment variables, not the arguments? Yes, it is the Thank you very much, Lee Cannon. I was having a mental yeah, something was going wrong in my brain there. Okay, sorry. Let's go. It's in where is arg stored at? It's Zig stores them. Let's look at start. I'm like having a mental gap lapse. Where are these args? Arg. Actually, let's look at process real quick. Argzalic, where does it get args from? I swear there's a global somewhere where they're stored. So args with allocator. Yeah, args with allocator. Arg iterator. Okay, arg iterator. POSIX, there we go. os.argv. There it is, argv. Populated by startup code before main. Not available on Windows. Okay. Wonder if we should make this available on Windows, by the way. something to think about. Okay, argv. So let's go back to zig start. Where's my environ? No, thank you. argv. argv. Maybe we won't need the pointer cast anymore. Maybe we'll get lucky. Yeah, so let's see if this lets us do it. Expected type as cannot convert optional to payload type. Consider using what if I do like this kind of looks like it might be just a bug in Zig, but no matter. We'll just use the cast for now. Not a big deal. That's looking better. Okay, so we got an arg. Okay, no, that's better. argv. Okay, so we return a question mark, and then I was calling stircur. dep cmph source main getopt. Okay, so it's calling getopt. What does it do when it sees a question mark? I don't see any question mark. So it does, okay, so it goes to the default use case and it prints usage. Usage. Who's calling? Oh, stircur is probably, yeah, it's being called by our printf implementation. Yeah, so it's looking for a % symbol. Yeah, so this is just the format string stuff. Let's turn off the tracing real quick. See what it looks like without it. So we should just see a usage. Yeah, usage. It's looking pretty good. Hello? Okay, what if I do -v? It wants a keys file. Okay. I don't think I've ever actually used CMPH. Maybe we look up how to use it. CMPH. Oops, CMPH. Okay, we want to look for CMPH, the command line program. Okay, I wonder if they have a keys file somewhere in the repo. Examples. Okay. There's an HTML file. Using CMPH is quite simple. Take a look at the following examples. Download. Okay. Well, let's just make an empty file. Touch keys file. Oh. Because I returned a question mark, it's just thinking that there's no arguments. Okay, so yeah, let's look at what it's doing. Getopt. So what happens if you don't have an option? What do you what does Getopt return? Does it? I don't understand what Getopt does here. Maybe it's after you call Getopt. Okay. So the non-option arguments is left in opt-end. Okay. So does it like move the arguments around within argv? An element of argv that starts with dash is an option element, okay? If Getopt is called repeatedly, it returns successfully each of the option characters, okay? Okay, the variable opt-in is the index of the next element to be processed in argv. The system initializes this value to 1, okay? We can do that. The caller can reset it to 1 to restart scanning of the same argv, or when scanning a new argument vector. If Getopt finds an option character, it returns that character, updating the external variable opt-end and a static variable next car. Okay, I don't know what this next car is. But when we saw a dash, we're supposed to set opt-end. I think it's supposed to be opt-end here. I'm guessing we increment it here. Well, maybe we always increment it. I think that's probably more correct. If there are no more option arguments, Getopt returns -1. Okay. Then opt-in is the index in the argv of the first argv dash element that is not an option. So does that mean that opt-in and opt-in to +1, so does it move the stuff around? I'm not sure. For now, we're going to do the probably incorrect thing, but also the simplest thing. So if it does not start with a dash, we'll just say, I actually probably want to keep opt-in where it is, and then return -1. So I think this is probably incorrect, but we'll start here because it's the simplest interpretation. Okay, so that did get us past the initial part. Let's see if libc test has some Getopt stuff in it. Okay, there's an API, which you don't really care about. And they have it looks like it's just 2 command line tools. It doesn't look like there's a lot of Getopt testing here. We can make our own though. Maybe we make our own Getopt test. Okay, why is there a getopt.c in our test? I don't remember writing this. Where did this come from? Maybe I have a vague memory of it. It must be disabled. Yeah, I don't remember writing this. Just build for now until I implement Getopt. Okay, so let's actually try to run it. Oh, I think we are hung. Getopt dot. Yeah, so we're... How could we get into an infinite loop here? wonder if my test is invalid. So we're doing while it does not equal -1. If we see a question mark, let's have a default case. Printf standard error, huh? Turn 1. We did see the huh. How to handle %C. C. How to handle. I haven't implemented %C in printf, so we're going to use %D. -1. Okay, so why? That should have broken the loop, right? Okay, something funky's going on here. Should be does not equal -1. Isn't that what it is? Does not equal -1? Or was there a problem in my no negative? Oh, thank you. Okay, very good. That's why we were hanging. We'll just go assert 0. We should never get there. Okay. So it looks like we probably need to print a success here. Okay, so that actually got the test to pass. We probably want to run it with some different arguments though. So let's try that. Okay, let's try adding arguments this time. Run dot, what is it? What is that API? Zig, glib, standard, build, run step. Fn add arg. Add args, that's what we want. Add args. And it wants an array of strings, so I could do this little shorthand syntax. Okay, so this, what does the colon, is it colon and then option? Getopt. Here. This one has a colon after the C, which means C takes an argument. What does it mean before? Colon. A legitimate option character is any visible 1-byte ASCII character for which isGraph would return non-zero. Oh, I didn't know that. isGraph. What does isGraph actually do? Checks for any printable characters except space. Oh, that's good to know. And it can't be a dash, a colon, or a semicolon. If such a character is followed by a colon, the option requires an argument. Yep. So Getopt places a pointer to the following text in the same argv element or the text. 2 colons means an option takes an optional argument. How does that work? Like, how do you know? I suppose if the next argument had a dash, you would know it was omitted. Interesting. And the same word is that, okay. Then it is returned in opt-arg. Otherwise, opt-arg is set to 0. Okay, but where does the colon mean before? Actually, you know what? I don't know where I got this example. Maybe this example is just invalid. I'm sure if I Google Getopt example, it'll be like one of the first ones. Well, maybe not. Let's scratch this one then and use like this one. So we're going to go with ABC colon. Okay. Let's make sure our test still passes. Yep. Okay, let's pass a dash A. Case A. And in this example, they just set this A flag thing to 1. Let's put this in its own scope here. Int A flag equals 0. 1 break. Okay. Dash A. And in this case, we could do success. Let's just print A flag equals %D. So in this case, A flag equals 0 and A flag equals 1. Just for sanity check, let's make sure it fails when I do that. Uh-oh. That's not supposed to happen. What did I do here? Oh, I'm running the wrong target. Whoops. Okay. So we expected A flag equals 1, but we got A flag equals 0. Okay, so for some reason, argc equals, let's just make sure, got our arguments here. Okay. Args equals 2, yeah, that should be good. Okay, so we're getting the argument. Yeah, and it's failing, I think, because I haven't implemented it, that's why. Am I passing a dash A? Yeah, I am passing dash A. Okay, so let's take a look at Getopt then. If it equals, we should be seeing a panic here. Center.log.info arg is arg. Okay, why aren't we getting a panic? Arg is dash A. So we're saying if, we should be seeing this panic here. Oh, it should just be arg. There we go. Now we're getting a panic. And in this case, we'll say if arg2 does not equal 0. Panic multi-letter arguments not implemented. Otherwise, we should probably check whether this option is in the opt string. So let's do that. We can do that with stir_cur. c.stir_cur. Opt string arg +1. Or else we return a question mark, I think. I think we return, but I'm just going to panic for now. Unknown option. Probably return oh, and this shouldn't be a +1. This should just be the like that. Okay, otherwise we've got our result, and then we can check if there's a colon afterwards. So we could say takes arg equals arg result 1 equals colon. If takes arg panic options that take args not implemented. Otherwise, I think we set opt arg or something. Maybe we don't do anything. We just return arg1. Let's just try that. U8. Oh. Line 33. Cannot cast negative value -1 to unsigned integer type U8. But it's not a U8. It's a cint. Huh? Okay, yeah, it didn't do anything. I think it would return 1. What are you going to say now? Okay. Return 1. I'm sure I did something stupid again. Like when I didn't have that negative on that 1. What's going on here? Why can't I return -1? Why are you saying the return value is a U8? And what's weird is it was working before I added this code. Is it going to work again if I comment it out? It is going to work again. Okay, so something in this code is causing it to not work. Okay, it's not that. Maybe it's this or else or something. Okay, it's not that. Let's try this one. Okay, that's fine. So it must be this return here. It's messing it up. Yeah, this return's messing it up somehow. Yeah. That's so weird. So I'm returning a U8 here. And what that that's interesting. So the compiler thought the return type was a U8 because one of my returns was returning a U8, even though it's explicitly set to a cint. So that's just a bad compiler message. Hopefully it'll get fixed in stage 2. I'm not going to open an issue for that. Cint. Okay, that's better. Okay, so our test actually passed now. Let's also check passing arguments now. So car star C arg equals null. Case C. And how does C work? Optarg. C arg equals optarg. Break. Okay, so then we'll print C arg. C arg equals. What is C supposed to do when you print a null? Printf S is %S. Okay, yeah, I thought it did this. It prints like this parenthesis null thingy. Is that like a standard thing or what? It doesn't like it. What if I cast it? Or car star equals null. Does that make you happy? Warning, %S directive argument is null. So it's like it's giving me a warning for passing null, I think, because if I pass like hello in here, probably be, yep, it's good with that. So you get a warning if you pass null, but it doesn't crash or doesn't do anything bad if you print a null. It just changes it to null. Let's see if like the C standard says anything about that. Look at the C89 standard here. Printf, formatting, null. Oh geez. Printf again. Okay, this is the section I want to search here. Where does it talk about the S flag? Well, I think for now we'll duplicate the behavior that we're seeing in glibc. So let's implement that. It's going to be in source/libc.c. For those that don't know, all of the var arg stuff is currently implemented in C because Zig doesn't have a way to do that as far as I know. But we could add a way to do it using assembly at some point, and then it will all be in Zig. But for now, we're doing it in C. Here's how we handle the S specifier. So all we can do here is we can just say if S equals null, S equals null. Will that work? Yeah, I think it will. Yeah, that's all I need to do. Okay, so let's go back to our Getopt and carg build.zig. Carg equals null. Yep, that works. Let's add another one where we pass in a dash C, a hello, okay, this won't work. We should get our panic. Yep, take arg's not implemented. POSIX. Okay, so if it takes an argument, then we need to is optional result2 equals colon. Yep, actually, if takes, we should only check that if this one equals a colon. Otherwise, this one could be null, and then we'd be going past the string. So only if we take arg do we check that. So if is optional panic optional args not implemented. Otherwise, I wonder if the arg, it probably is supposed to not have a dash. So we'll say okay, if global dot opt-in, if we're done, greater than or equal to argc, then it's missing an argument, and I think we return a question mark. I think we saw that in the example a while ago. But we'll panic for now. Handle to do handle missing arg for option. Okay. And then we'll also say, or see arg v global dot opt-in 0 equals dash. Okay, otherwise we have our option, so we'll set opt arg, I think. Okay. And I think that's all we need. Let's try it out. Global. Because argv is null terminated, we can just set this beforehand, because in the worst case it's gonna equal null, so we can't dereference it, so never mind. No, it's fine, because we won't dereference it unless opt-in is less than or equal to argc, so I think we're still fine here. Oh, the test passed. Okay, so our Getopt supports most things, I think, now. Let's make this case first and decrease the nesting here. So to do, not sure if this is what we're supposed to do. My guess is we have to take this non-option argument and move it to the front of argv, then move on to the rest of the arguments to check for more options. I think that's what we're supposed to do, but And maybe we should detect this. So maybe we should do this. We can say if global dot opt-int +1 not equal argc panic to do check the rest arguments. Yeah, I'm pretty sure we need to check all the arguments. I'm almost certain. So we'll just panic in that case. We haven't implemented it yet. Okay. Should we, what we have now I think will work for CMPH. So maybe we can stop there for now on Getopt. And we'll pass our key file. What was it, foo? Okay, let's move on from Getopt for now. Now let's get our tests uncommented again. Okay, that's all the steps I can think of right now to test. Okay, so we added a few more tests for Getopt. It's so funny, I added the test and I just forgot about it. Okay, we added this. Let's add a comment there. No, it was libc.c. To do, is this how we should be handling null string pointers? Okay, here's our Getopt implementation. Simple, hacky, just how I like it. Do we want to increase the max trace string to 30? Maybe like 26. Yeah, 26 is good. Zig start. Probably okay. And then our Getopt test. Probably okay for now. Implement some Getopt. Yeah, let's move on to the next piece for CMPH. See how far we can get. Ooh, okay. That took a while. Okay. fseek. Fseek's pretty easy to implement. It's just a syscall. So libc.zig. Let's see. Let's look up the seek system. No, let's look at standard OS. rg fn seek. No, I just want to look in OS. Oh. Okay, maybe not. I see one in file. Okay, I think the one from file is probably what we want. So we can do standard.fs.file.handle equals stream.fd .seek to or seek by. Let's see, what does it have? It's got seek to, seek from end, and seek by. So I think all these are like the whence. So let's, maybe we do a switch on whence. C dot seek, what is what is those values? Inc. Or in standard IO, so libc standard IO. Right here. Seek set, seek cur, and seek end. Seek set. And do all these have the same signature? Offset, offset, yeah. So actually we can, oh, one of them takes a U64 though. So that won't work, never mind. We could have done something, could have used a little function pointer and been clever. That's okay though. Okay, so in this case they all return a seek error, so okay, we'll go const file equals this. File.seek, I think it's probably seek2, is the from start repositions relative to the beginning. Yep. So seek2 file offset. Okay, so const result equals cur and seek end else. I wonder what it does. Let's check out what GCC does. Printf, or let's go, what does fseek return? An int result equals fseek, standard IO, 0, whence, let's give it like 900. Here now. So result should be -1. Did I mean standard in? $22? Is that like E and val or something? No, that's the one I want. 22. Yep, E and val. Okay, so error no equals C dot E inval. Actually, we can go standard.os dot E dot inval, I think. Return -1. Yeah. Okay. Actually, you know what? I don't know if we want to call the zig seek functions, because then we're just like converting the zig error code back to a C error now. We just want to see what standard OS is doing. No, files where it was. os.lseek. That's the syscall, I think. lseek. Yeah, that's what we want. lseek. So const result equals standard.os.lseek. Is there one that takes an argument? Set, cur, and end. Okay, so maybe what we do, no, we still want to, we don't want to call this one because it also returns a seek error. There's an llseek. What is this llseek? Well, let's try calling it stream.fd offset. It returns a U64. Okay. Offset high, offset low. Oh. So I bet this LLSeek is a wrapper that's converting this 64-bit offset into like a high and a low. And then the results, it's also turning it into the RC, I think is what Zig uses a lot here. So results, and then the whence. Okay, switch RC dot success. Okay, so in the success case, what does fseek return? A successful call clears the end of file indicator and undoes any of the ungetC function. Okay. Turns non-zero only for a request that cannot be satisfied. Okay. So on success, we will return 0. Otherwise, we will set the error no equals and return, I don't know what we return, like maybe -1. What do we return? It doesn't really say. Maybe let's see what muscle does. Turns -1, returns -1. Okay, yeah, it looks right. Let's try it out. Okay, expects U64, found ulong. Expects usize, okay. It's getting big, I guess, so maybe we go to multi-line at this point. Okay, so LLSeek. This might be a bug in the compiler or the standard library. There's no LLSeek in the syscall enum. That's interesting. There's also lseek though, and I think lseek's is all we need. So let's use that instead. Okay, so it's const rc equals ossystem.lseek stream.fd once. Yeah, just get rid of this. We just need lseek. We don't need llseek. very cool. So fseek seems to be working this out of trace here, just to see. Fseek pointer offset equals whence equals stream offset whence, and then we'll enable our trace here. Oh, I actually haven't even looked at the trace yet, so we can see what it's calling. It's calling time. It's seeding the random. I do have random implemented, I think. It's calling strlen. Okay, it's getting the length of the file name we passed it. And calling strlen again on it. It's opening the foo file in read mode. Creating 40 bytes. Assert. Okay, it's calling an assert with a non-zero value, so that should be fine. It's calling rewind. I don't remember implementing rewind actually. Fn rewind. I did implement rewind actually, I do remember it now. Yeah, it just calls fseek and then removes the error no. Actually, I was wondering how rewind returned an error, and maybe what I do here is I don't return an error if I don't clear the error no if it fails. Maybe that's how it works. I kind of like that. Fseek. So fseek, does it return the error in error no or the file? All right, let's just do this. So if 0 equals, then we clear it, otherwise we don't. Should we set stream.error note if fseek failed? Yeah, I don't know if fseek sets it in the, because you have your global error node, and then each file stream has its own error node that it can keep track of too. Okay, so rewind. And that calls fseek, okay. With 0, 0. Cool. fgets. I think we'll probably do one, maybe two more, and that'll probably be it for this stream. Yeah, let's see, maybe we can get fgets implemented. This will, I don't think I've implemented any input. I haven't implemented any input stuff, and I haven't done any input buffering yet on the files. Let's take a look at fgets. Maybe we can do something simple for now. Reads at most one letter, one less than the number of characters specified from n. Okay, so leaving room for a null. No additional characters are read after a new line, which is retained. So it stops at a new line. Okay, so in this case, our streams would have to have an internal buffer, and maybe they have like a pointer to a buffer that starts out being null, but then when you start reading input from it, you allocate a buffer. And it has to be large enough to hold, like, let's say you read in a string. Well, I suppose you don't have to buffer anything. What you could do is call read, and then if you read too much, you fseek backwards, back to the new line. So then the next read will reread what you need. That would definitely probably be less efficient than just caching it in memory, but it would get rid of some state that you'd have to keep managing. I think for the initial implementation, we just care about correctness and simplicity. So maybe all we do is we just read one character at a time, and start with that, because then we don't need to have any state, and then we can worry about making it fast later. So I think we can actually call fgetC, which maybe we implement fgetC first, or getCar, what is it? getC, okay. For some reason, getC doesn't have an F before it. Who knows why? So let's fgetC, or fgetS, let's have it call fgetC for now. Or getC. Okay. Now getC is not implemented. So this one should just be a simple call to the read_sys_call. So we'll go const result equals center.os.read var buff1 u8, and this will be stream.fd buff1. Should that compile? Okay, so if result does not equal 1, then we got an error. Actually, I think I want to call system.read. Okay, so if it succeeded, then we return our character. Else. Error no. Ooh, what does getC? Does it set the error no? If the stream is an end of file, the end of file indicator is set, and getC returns EOF. If a read error occurs, the error indicator for the stream is set, and getC returns EOF. Okay, so we'll go stream.errorNo equals enum to int on E, and it also returns EOF. Okay. Does that look right? Oh, in this case I need to check if RC equals 1. Maybe I don't do this in RC equals 0, then we're at EOF, so return stream.errorNo equals 0 probably, return c.eof. The most common case is going to be this one. If RC equals 1, then return buff 0. Maybe those are fine. Otherwise, we're here. Actually, maybe we do that. And maybe we do this. Oh, we don't have our E anymore. That's okay. Okay, I think that's right. And we can do like a trace.log getC return buff 0. get C, return EOF, error no equals this. I think that's because our foo file is empty. Oh. Oh, it probably has a new line in it. I already made a file named foo and put some Lua code in it, so when I touched it, the file already existed. Oh, that's funny. Okay. Okay, F get S. Okay, so all we do now is we go into a loop here. Var total red U size equals 0. If total red is greater than or equal to n minus 1, then S is that right? But you may not want to do a minus 1, and you want to do a plus 1 in case n is 0. So if total red plus 1 is greater than or equal to, it might even be plus 2. So in the 0 case, let's say that they passed in a buffer of 1. We would immediately have to stop reading. So how would we make that work? So if total red plus 1 is greater than or equal to n, then we would be done, and we would go S total red equals 0. Yeah, I think that's right. Does F get S just return S? Probably. Returns F as S is if successful. Okay. So return S. Otherwise, we will get the next character. So S const result get C stream if result equals C.eof. Then there's either going to be an error or there's not going to be an error. If there is not an error, we return S probably. So we go if stream dot. Now in this case, we are checking the error no, so we probably have to be setting it to a not error here. Yeah. If stream dot error no equals 0, then we're good to go, and we say S total red equals 0. Return S. Else, I'm guessing we return a null. Okay. Otherwise, we return null. And if it's successful, then we say S total red equals int cast weight of result. And that should always, I don't need to AND it with anything, that should always just work. Okay, I think I'm missing, am I missing something? Yeah. Total red plus equals 1. Very cool. So we're calling get C, return 35, 33, 47, 104, blah, 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 blah. And then at the end, we get an EOF. Okay. So now CMPH is checking whether the fgetS failed or if we just hit the end of the file. And it's calling FEOF for that. So I actually haven't implemented FEOF. I could possibly utilize the error no, but maybe not. Let's just add an end of file field to it. Standard IO. Okay, so that means when I initialize it, I'm going to have to set the EOF, I think. Yeah. So we want it to be initialized to 0. Let me see how I'm implementing. .EOF equals 0. Or, yeah. And then when we reserve a file, we'll need to initialize it. Files I.eof equals 0. Yeah, I think that's all we need to do. Okay, so if stream.eof panic eof not 0, not implemented, stream let's see, let's just add a bunch of panics. Make sure it still builds. Okay. Fn, okay, so let's look for all of our stream functions. So getC we took care of. UngetC. Let's leave breadcrumbs everywhere so we know that we need to go back and look at all these. Now we can implement this. Return stream dot EOF. FEOF. Returns a non-zero. Yep, so that should be all we need to do there. Well, I initialize FD here. I wonder, maybe I should just initialize EOF here. Reserve file. Reserve file. Yeah, I'll just do it there. Okay, F reopen, F close. We don't care if there's EOF there. F seek. Would we care? I don't. F seek did say that it would change whether EOF is set. So I'm just going to add a to-do here. Update EOF when applicable. Okay, ftell. Okay, it's not implemented, so we don't care. Stream.eof equals 0. F put C. And F get S. So if it's EOF, we could probably make this an early escape patch. We just say return null, I think. Yeah, I think that's all we need to do. Okay, I think we got further. So called ferror. Then it called strlen on, I believe, turn 68. Is that the size of the file? Yep. It's calling strlen on the file contents for some reason. I'm not sure why. And then it calls getC on the file again? Okay, what's this thing here? Oh. So the string that was returned, the string that the file was written to, now it's like empty for some reason. So that's the same address. Huh. Now that may or may not have been, oh, but this is so cool. We can look at the stack trace here. So it's doing, oh, look at this. So it's calling buff with strlen, and we just saw strlen return 0, and then it's subtracting 1. Let's see, hold on. Where was libc.zig fgetfs? Because fgetfs is supposed to null terminate. Maybe we forgot to null terminate it or something. We null terminate it here. We null terminate it here, otherwise we return null. I think that's right. Let's look at this code for a sec. 169. Count NL file, like new line file keys. Okay. Oh, it could just be like, since our file's not, oh, I wonder if it like needs to be ended in a new line or something. What if we just go A equals B, something simple like that. Yeah, we see our A equals B. If we're at the end of the file, we break if there's an error or pointer equals null, we get an error. Otherwise, oh, it's calling strlen because it doesn't, when you call fgetS, you don't know how big the buffer is. Oh, goodness. fgetS, wow. So it's calling strlen. Oh, we forgot that fgetS is supposed to stop when it sees a new line. If s total red equals new line, then we say s total red plus 1 equals null, return s. Maybe that'll make it happy. Not quite. strlen returned 4, hold on. 0, 1, 2, 3. Yeah, so it's checking if 3, and then it's calling rewind. I don't see a rewind call, so I'm not sure. Oh, it's reading it and then it's calling rewind after it reads it. Okay. So we'll get like this should equal a new line. It increases the count and then it tries to read it again. And it should return Hmm. Yeah, I'll have to debug this more. I think I'm good with that for now. Let's take a look at our changes here. We added EOF, implemented some getC, some fgetS, feof. Looks good for now. Let's not leave our trace stuff in. And are there any new files we need to implement? No. Okay. So implement some get libc functions. Cool. So yeah, that's some good progress. We got some more functionality with files implemented, some reading of files, some Getopt functionality. So we're making good progress. Here's the repository. And yeah, if anybody wants to try it out, build, let me know if you see any issues or have any ideas. What I'm doing right now is getting the initial implementation going, and then at some point it'll be a lot more dynamic and configurable. So instead of manually creating these headers, they're going to be generated through some sort of process. And the idea is that they'll be universal. So yeah, so we'll get the first version 1 going. That'll be manual, and then we'll automate that so we can use it with any libc backend that we need. So anyway, if you dropped by, thanks for watching, and we'll see you next time.